Hello there, this is Sachin sir and welcome back to Max World. In today's video, we will try to understand the coordinate geometry. Okay. Before starting this lesson, let's try to figure out or recollect some previous knowledge about the lesson. The basic knowledge that we require for this lesson is nothing but about the number line. Here is on the screen. This is slipping of the horizontal number line, also called as x-axis, where O or the 0 represent the origin. Okay. Consider point A and B as shown in the figure, where coordinate of A is 2 and for B it is 6. Now, do you remember how to find the distance between these 2 points? Yes, it is bigger coordinate minus smaller coordinate, and the moment you do this subtraction, that is 6 minus 2, you get the answer 4 units. And always keep it in mind, the distance between any 2 points is always a positive number. Okay, so that's why we can say we can always get the number in the modulus. Okay. Furthermore, what if along with the horizontal line a vertical number line is also given to us, that is y-axis, and these points A and B are not on a number line, that is x-axis, but somewhere in the first quadrant, but in such a way that both point A and B will have same y coordinate. Okay, that means segment AB will be parallel to x-axis. Okay, in that case, if you want to find the distance between point A and B, again always keep it in mind, if the segment is parallel to x-axis, then the distance is nothing but x2 minus x1, because they have same y coordinate. Keep it in mind. Now what if these points are now, instead of getting parallel to x-axis, parallel to y-axis, where same there, as they are parallel to y-axis, their x coordinate will remain same, that is x1, and they have different y coordinate. Okay, so in this case, that is when the segment, that is AB segment, is parallel to y-axis, and distance between them will be calculated by the difference between their y coordinate, that is y2 minus y1, or same thing, bigger coordinate minus smaller coordinate. It is up to the numbers that you get. Okay, these are the 2-3 conditions that we should know before starting our lesson. So in short, what we have learned that to calculate the distance between any 2 points which are present on the axis, we have to do bigger coordinate minus smaller coordinate, provided that they are present on the same axis. Second condition, to find the distance between the point which are making a segment in such a way that it is parallel to x-axis, then we have to find the difference between their x coordinate, that is x2 minus x1. What is the condition? The segment will be parallel to x-axis. Now if the segment is parallel to y-axis, then we can calculate the distance between those 2 points by finding the difference between their y coordinate, that is y2 minus y1, or you can do y1 minus y2 also, but see that which one is the bigger coordinate. It's up to bigger coordinate minus smaller coordinate. So it can be y2 also sometimes, it can be y1 also sometimes. Okay, so be careful about that part. And now here is the main part of the lesson. What if these 2 points are not parallel? These 2 points are forming such a segment which is not parallel to any of the axis but intersecting it. So here on the screen, the way you are looking at the screen, segment AB is not parallel to any of the axis, right? Now how to calculate the distance between these 2 points? Now very first, if you consider point A, that is x1 y1, and for point B coordinates are x2 y2, right? Now extend and intersect the coordinates which are on the axis, the way you are looking in the diagram, and now extend the segment from A in such a way that it will be perpendicular to the segment which is passing from point B and intersecting x-axis, the way you're looking, and name it as point C, the way you're looking in the screen. And do not forget that as it is a perpendicular, so 90-degree sign will be there. Now we have a right angle triangle on the screen, and now I need to find the distance between AB, and whenever we have right angle triangle, then the god of geometry, that is Pythagoras, will be there for sure, right? So according to Pythagoras theorem, what do we have? We have AB square equal to AC square plus BC square, right? Hypotenuse square equal to side 1 square plus side 2 square. And now if I'm able to figure out the distance between AC, point AC, and point BC, then ultimately I can solve the sum, right? I can find the length or the distance between point AB. Now what to do? Observe the diagram. segment AC is nothing but parallel to x-axis, and as it is parallel to x-axis, what can you say? The distance between AC will be nothing but x2 minus x1, right? Yes. Why I got x2? Because point C, if you observe in the diagram, for the point C, their x coordinate is x2 and y coordinate is y1. Isn't it right? Yes. Now moving on, what we have got till now, AC square, although AC, the distance between point A and C is nothing but x2 minus x1, right? Consider now segment BC. That BC is parallel to y-axis, and if it is parallel to y-axis, then ultimately we have to take the difference between the y coordinates, that is y2 minus y1, right? And hence for the BC we have y2 minus y1. Do not forget to mention the square as sides are given in a square. So in short, what we have, AB square equals to x2 minus x1 the whole square plus y2 minus y1 the whole square. From where we got these values? Because the part of a segment that is formed on the quadrant, that is first quadrant, is nothing but parallel to x-axis, and other one is parallel to y-axis. Now as we require only AB, then we have to find the square root on both the side, and as a result we get the answer AB equals to under root x2 minus x1 the whole square or y2 minus y1 the whole square. This is what our distance formula is. Boys and girls, keep it in mind, we can also write this formula in this manner, that is AB equals to under root x1 minus x2 plus the whole square, of course, plus y2 minus y1 the whole square. Always keep it in mind. What you have to remember, once you have taken x1 in the first bracket before the subtraction sign, then in second bracket we have to take y1 before the subtraction sign. Okay, so till now what we have learned, if a segment is parallel to x-axis, then its distance is nothing but x2 minus x1. If the segment is parallel to y-axis, okay, then the distance between their point is nothing but y2 minus y1, or the bigger coordinate minus smaller coordinate, and the distance between segment between points which is not parallel to any of the axes is calculated by distance formula, and that formula is under root x2 minus x1 the whole square plus y2 minus y1 the whole square. Now we will try to solve a few questions based on this formula. So here is the first sum on your screen. It is 5.1, question number 1, and in that first question says that I need to find the distance between point A and B, where coordinate of A are 2 and 3, that is x1 and y1, and coordinate of B are 4 and 1, that is x2 and y2. Now of course we are going to utilize distance formula. By distance formula, what do we have? We have AB equals to under root x2 minus x1 the whole square plus y2 minus y1 the whole square. Now do not forget to substitute the value very properly, very sharply. Okay, you have to observe the sum properly. Now very first, what you have to check, x coordinate of both the numbers, the way you are looking on the screen. What is that? 4 and 2, right? x2 minus x1, that is 4 minus 2, and for the y2 minus y1 we have 1 minus 3. Okay, so here we move on. Once you carry out the subtraction, 4 minus 2 we get the answer 2, and 2 square we get the answer 4. 1 minus 3 we get the answer negative 2. Square of negative 2 is nothing but again positive 4. During the squaring, though the number is negative, your answer or the square will always come in positive. Okay, so what we have 4 plus 4. As a result we get under root 8. So in short, AB equals to root 8. Here also we can go ahead. If you find the prime factor of 8, what do we get? We get under root 2 into 2 into 2, and as it's a square root, the order is 2. So what we can do, a pair of 2 can be removed outside, right? And as a result we get the answer AB equals to 2 root 2 or 2 under root 2. So in short, my final answer is distance between point A and B is 2 root 2. So here is the next question on the board. The question is, point P has a coordinate minus 5 and 7, that is x1 y1, and point Q has a coordinate -1 and 3, that is x2 and y2. Now again we move ahead with the distance formula the way you are looking on the screen. Now while substituting the value in the formula, you have to be very cautious, very careful. Now very first check both the x coordinate. We have both negative numbers, isn't it? Yes. So x2 minus x1, that is -1 minus -5. Okay, the way I have mentioned in the formula, do not forget to mention the value in the same manner, okay, to avoid the confusion. Similarly, for the y, if you observe, we have 3 and 7, right? So that gives me 3 minus 7 the whole square again. The moment you carry out the subtraction, you will get -1 minus -5. So that minus will turn into positive. That gives you -1 plus 5. Okay, according to rules of integer, -1 plus 5, you get the result plus 4, and that is why it is written 4 square. In the second bracket, 3 minus 7, bigger number sign, yes, that is -4, and that is why in the second bracket I got -4 the whole square. The moment you carry out the square, you get both the number positive, because the way I told you, doesn't matter whether number is negative or positive, after squaring it, you will always get the number in positive. So what we get? We get 16 plus 16, that results in under root 32. The moment you carry out the prime factor of 32, you will get 5 times 2, right? That means 4 2 are there which can be paired, right? And as a result, I get the final answer as 4 root 2. Isn't it right? Yes. Do not forget to mention the final answer the way you are looking on the screen. And here we go with the next sum on the board. That is, for the point R, we have coordinate 0 and -3. For the point S, we have the coordinate 0 and 5 upon 2. Yes, it's a fraction. Now, the way I have mentioned x1, y1, x2, y2, don't forget to mention that part. After that, distance formula and mention the formula. After mentioning the formula, the moment you substitute the value, the easiest part is what you know, 0 minus 0, you will get the answer 0. Yes. And for the y coordinate, we have 5 upon 2 minus -3, right? y2 minus y1 the whole square. This minus -3, that gives you positive 3, and that is why we have 5 upon 2 plus 3 the whole square. Now, addition of fraction and a number, we have certain rules to be followed. So let's see those rules first of all. Here on the screen we have 5 upon 2 plus 3 upon 1. From where I got the 1? Only 3 is nothing but 3 upon 1. Always keep it in mind. So after that we carry out with the thumb dance. This is 5, 2, 3 upon 1. So what we get? 1 into 5, then 2 into 3, and then again 2 into 1. This is called thumb dance or LCM method to carry out the addition of two fraction or fraction and a number. Always keep it in mind. So as a result, we get 5 plus 6 the whole upon 2. After carrying out the addition, that results in 11 upon 2. So in short, the addition, the answer of addition, that is 5 upon 2 plus 3, we get the answer 11 upon 2. So move on with the sum now. Presently on the board we have RS equals to under root 11 upon 2 the whole square. Yes, whole square means what? 11 upon 2 twice, 2 times the way you're looking on the screen, and as it is 2 times, so 1 time 11 upon 2 can be taken out, right? Moreover, we have certain rules of the indices. Square root of a square is equal to a. Listen carefully. Square root of a square is equal to a. In that manner, if we apply that rule, we get the answer 11 upon 2 directly also. So final answer is distance between point R and S is nothing but 11 upon 2. So here we go with the next sum on the board. The question is, we need to find the distance between the point W and X. Here the coordinates of W are -7 upon 2 and 4, and for the X they are 11, 4. Have you observed something? Here y coordinate of both the number is same, and if y coordinate is same, that means that segment is of course parallel to x axis. Isn't it right? Yes, that we have learned previously. So instead of solving this sum by distance formula, we can use that shortcut way to get the answer of this distance wx. What we know, if the segment is parallel to x axis, then the difference between x coordinate will be the distance of that segment. So distance wx is equal to x2 minus x1 directly. As a result, we get 11 minus in bracket negative 7 upon 2, right? That minus and negative sign together, they result in positive 7 upon 2, so we get 11 plus 7 upon 2. After that, thumb dance, yes, 2 into 11, that results in 22, 1 into 7, that results in 7, and 2 into 1 results in 2. So we get 22 plus 7 the whole upon 2 as the result after carrying out the addition. That gives us the answer 29 upon 2, and this is what we needed. Therefore final answer is distance between point W and X is 29 upon 2. Don't forget this part. Now one more sum is there in the exercise that we have done previously, that can be solved with this method. Here the segment was, here the y coordinate was same, but that in that sum x coordinate is same. Yes, you are right, previously we have done it. So you can solve that sum also with this method. Now we are going to solve question number 2 of the exercise, that is to decide whether given points are collinear or not. Collinear point, while deciding it, okay, we are given with the 3 points, coordinates of each point is given to us, and after that what we have to do, we have to decide whether given points are collinear or not. So what is our action plan for this question? Very first, as 3 points are given to us, so we will make 3 sides from those 3 points. Suppose ABC is given to me, right? So AB, BC and AC, these 3 sides or 3 segments will be formed, and we have to calculate the distance of this segment, okay, by distance formula. Once you calculate 3 distances, then only one thing to be checked. What we are going to do, from those 3 distances, take out the bigger one aside, add remaining 2. If the addition of remaining 2 sides is equal to the bigger one or the biggest one, okay, then the points are collinear, and if it is not equal, then points are not collinear. So here we go with the first sum on the board. The points are same, ABC, the coordinate of ABC are given to us the way it is shown. Can directly apply the distance formula for AB. The moment we start applying the formula, what do we get? We get x2 minus x1, that is 1 minus 2 the whole square, right? Because both the coordinates are 1 and 2, okay, for the x coordinate. And after that, plus in bracket negative 3 minus minus 5 the whole square, okay. So over here, that negative and that minus for the 5 together will result in positive 5. So what we have there? We have negative 3 and plus 5. In the first bracket we have 1 minus 2, that results in negative 1 the whole square, right? For the second bracket we have negative 3 plus 5 now, okay, so that results in 2, and 2 square is 4. Don't forget that part. After that, the moment you carry out the square and then add them, we get the answer root 5. For the distance AB we have root 5, number it, that is the one. Now start solving to calculate the distance BC. The moment you substitute the value, we get 2 minus negative 4 the whole square, right? Then minus 5 minus 7 the whole square, correct? The moment you carry out the subtraction, you get the answer 6 square for the first bracket, right? Yes, of course, negative and then minus 4 will result in plus 4, and 2 plus 4 results in 6. For the second bracket, negative 5, negative 7, yes, 2 minus, we have to add it and then bigger number sign, that results in negative 12 the whole square. After that, carry out the square, you get the answer 36 plus 144, right? After adding them, that results in 180, so we have under root 180, and that gives the answer 6 under root 5, number it 2. Now third distance is AC. The moment you carry out the calculation by applying distance formula, we get the answer under root 125, the way you are looking on the screen, and after finding the prime factor of it, you get the answer 5 root 5. Now the first section, first part of the action plan is completed. What is that? To calculate the distance of 3 segments that we made, okay. So number it, 1 2 3 number, we have numbered it. Now once you check the distances, you will come to know that 6 root 5 is the biggest one, right? Root 5, 6 root 5 and 5 root 5. So 6 root 5 will be the bigger one. So write it aside the way I have written on the screen. After that, remaining 2 are, which are those? Root 5 and 5 root 5. We have to add them. So add them, what do we get the answer? Yes, 5 root 5, that is added by root 5. Only root 5 means 1 root 5. So 5 root 5, 1 root 5, together it is 6 root 5, and that is what our bigger side is, right? So in short we can say those are equal, and if those are equal, I can write BC is equal to AB plus AC, right? And if this happens, then the property of betweenness, we can say point ABC are collinear where BC will be the longest side. Okay, so the betweenness will be B dash A dash C, the way you are looking at the screen. I hope you have understood. So boys and girls, here we go with the next question on the board. We are given with the coordinates of point L, M and N. I need to decide whether these points are collinear or not. Same, we will utilize distance formula to calculate the distance LM, MN and then LN at last. The moment you use formula to calculate the distance LM, you will get the answer root 45 the way you are looking at the screen. After that root 45 can be turned into 3 root 5 by finding its prime factor, number it 1. Now substitute the value to get the answer for distance Mn. You get the answer under root 16 plus 49 after carrying out all the required operations. The moment you add these numbers 16 plus 49, you get the answer root 65, and this root 65 cannot be written in the mixed form because 13 for the 65 and none of them can be taken out of the root, right? Thirdly, we have to find the distance Ln. The moment you substitute the value, carry out the operation, you get the result under root 50. That 50 can be written as 5 root 5. Now if you observe all these three numbers, we have 3 root 5, root 65 and 5 root 2. Among these, two numbers are in mixed form and one number is in simple form, that is under root 65. So better to think about only simpler form, that is root 50, root 65 and root 45 for the calculations. Okay, so what we get by 1 to 3, we can say bigger number is under root 65, so write it aside. Remaining two numbers are root 45 and root 50. We have to add them together. We cannot add these two numbers because radicand is not same. If you remember the rules of search, radicand means the number which is inside the root, right? So we can say this addition is not equal to root 65, and hence we can write root 65, that is Mn, is not equal to Lm plus Ln, and hence these points Lmn are not collinear. After that, the next question is on the board. Here point PQR are given to us, their coordinates are given to us, and we have to decide whether these points are collinear or not. So very first step, we will find the distances of PQ, QR and then PR by utilizing distance formula, and all the distances are on the board the way you are looking it. Okay, so for PQ we have root 10, for QR we have root 10 again, and for PR we have 2 root 10, right? If you observe these three distances, you will come to know that 2 root 10 is the bigger number, right? So by 1 to 3 we can write 2 root 10 bigger one, so write it aside. Remaining two, that is root 10 and then again root 10, we have to add them together. So the moment you add these 2 root 10, of course root 10 plus root 10, 2 root 10, you get the answer 2 root 10, and that is equal to the biggest number, that is 2 root 10 for the value of PR, and hence we can say PR equals to PQ plus QR. And in this manner, by using betweenness property or property of betweenness, point PQR are collinear. So this is enough for today, boys and girls. For tomorrow we will carry out remaining sums of the exercise so that our 5.1 exercise will be completed. If you have any doubt, you can ask in the comment section below. I'll be waiting for that part.